Hi everyone, I'm Pete. I'm working on the Coora platform, which is a tool for developing autonomous agents. Uh, this will mostly be a technical demo, but briefly, my motivation for building this is based on the works of Seymour Papert and Brett Victor and the ideas that they put forward about the importance of tools in an education environment. Um, on top of that, this is also something that is very robust underneath and could also carry people through all the way to professional setting. So we've got both the education and the professional applications of this kind of tooling. The idea is good for the goose, good for the gander. If it's good for a high schooler to learn, then it's also very easy for professionals to develop. Some of the power that comes with this kind of approach is that it's using the techniques of AI we call behavior selection that's found in video games. It'd be the AI that's controlling, they call the NPC, the non-player characters, the enemies, or the companions that follow the player around. It's also the same techniques that are found in robotics. Robots in warehouses will have these decision-making tools. These can be like behavior trees. These can be utility selection or state machines. These kinds of tools that we use for developing. And I'll jump into the demo so we can see sort of how the approach is. This is a simulator. So the idea is that the simulator would be great for if you're making a game. You can test out your AI behavior logic before you put it in the game. And if you're if you're deploying the hardware, if you're making a robot, then you can test out the logic in the simulator before sending it off to the hardware. So here we've got what we call a utility selector. This one's able to look at the two children, and the two children are what we call actions, and you'd say, oh, okay, which one should go first? Now the difference between this and what you'd see as a simple if statement that you might be using a lot in Arduino or Scratch is that the children are able to tell the parent, oh, how important is it for me to go? So for example, this drive forward child is always going to go forward. It's always going to have a fixed we call score, fixed likelihood that it should go. And then we have this one with a depth sensor, which says, oh, if I get close to a wall, then it's really important that this action should run. And so that's a little bit of the difference between them. And you can see how that's a lot more modular. You can move that around. You could have like sub-processors, that sort of thing. Anyway, so we got the simulator running. I could, for example, change the distance of what makes this second one decide when to go. So if I put that really high and upload, it's probably always going to turn around because it's always seeing that distance, right? So I can sort of muck around with that. I'll put that back to, I think it was 0, it was 50 centimeters, that's right. Whoops. Okay, 50 centimeters, right. Okay, so that's how it was before. Now the second part of this, so let's say we've designed our behavior and we want to send it off to a robot. The second part of this is the hardware component. So here we've got our device list. A robot's connected via Wi-Fi. We don't need any wires. And also, because we're sending a graph across, there's no compilation going over here. We're just describing the behaviors that it already knows how to do, and we're describing the order and the parameters of those behaviors. So I'll see if I can get the video up, and we'll have a go at this. Let's see how it works. Okay, so this is the same program that was running in that simulator. I'm just going to connect it via remote control. And we see our robot's moving around, he's turning, and yeah, that's him driving. Okay, so as you can see, there's still a bit of work to be done, and we can work out the differences between the hardware and the software as we play with it. All right, I might go turn him off. Okay. So where are we? Oh yeah, so this is a very simple robot. It costs like $35 total on bought online. But you could also apply these programs to other kinds of robots. Arduino's new Alvic. We might be able to set that as a target or have different targets, that sort of thing. Anyway, yeah, that's pretty much the end of the tech demo. And yeah, I'm always open to feedback. So I'll put my LinkedIn the description of this video. If you'd love to have a chat, if you're interested in the project, or if you're interested in any kind of collaboration, yeah, really be very happy to hear from you.